You ever watch a cat investigate an empty box? Or, a baby just babbling away? There's no treat, no obvious prize waiting for them. And yet, this drive to just explore, it's one of the most basic things we, and pretty much every other animal, do. So that's the big question, right? Why do we spend so much time and energy checking things out when there's no immediate payoff? Well, to get to the bottom of this, we're going to tag along on the journey of a simple agent, all laid out in a fascinating research paper that tries to build a computational model for pure, unadulterated curiosity. So let's meet our hero, a learning agent. Imagine it's just been dropped into a world it knows absolutely nothing about. Its goal isn't to find some treasure or get to the exit. Nope. Its one single mission is to learn, to build a perfectly accurate mental map of its surroundings. And this map is what the researchers call its internal model. Now, this internal model isn't just some static picture of the world. It's way more dynamic than that. It's all about understanding cause and effect. It's constantly trying to answer the question, okay, if I'm standing here and I do this, where am I going to end up? The better it gets at predicting that, the better its map and its understanding of the world becomes. But, and this is a big but, our agent has a huge problem, the same one we all have every single day. It's embodied. It can't just teleport to the most interesting part of the world to learn something new. It's physically stuck in one spot and has to move, one step at a time, to find new information. This embodiment constraint is what makes having a strategy for exploration so incredibly important. So, how is an embodied agent supposed to explore efficiently? I mean, just wandering around randomly is going to be way too slow. It needs a guide, right? A tool that points it in the direction of maximum learning. You could almost think of it as an information compass. And that compass has a name. The researchers call it predicted information gain, or PIG for short. Kind of funny, right? Anyway, PIG doesn't point north. It points toward the action that promises the biggest, most valuable update to its mental map. It's basically a way for the agent to ask itself, okay, which one of my next moves is going to teach me the most? So how does this pig compass actually work? It's pretty intuitive when you break it down. First, the agent just imagines taking an action and thinks about all the places it might end up. Then, for each of those spots, it asks, how much would this surprise me? How much would this force me to change my map? And finally, it picks the action that, on average, is going to cause the biggest shakeup to its whole understanding of the world. But here's the crucial twist. Just looking one step ahead, well, that's not always the best move. Sometimes the most valuable piece of information is really far away, and it takes a whole sequence of moves to get there. So a much smarter strategy, which the paper calls pig with value iteration, or PIG-VI, actually plans ahead. It maps out a series of moves to get to those juicy, information-rich spots that are off in the distance. Okay, now for the fun part. The researchers took their PIGV agent and really put it to the test. They dropped it into 3 totally different worlds to see how its curiosity-first strategy stacked up against other approaches, like, just wandering around randomly. First up was the dense world. Just think of it as pure chaos. Every spot is connected to a whole bunch of other spots in a totally random way. There's really no structure to learn here, so it turns out just wandering around randomly works surprisingly well. No need for some complex, fancy strategy. Next, they tried the maze, and this is the complete opposite. It's a super structured world with walls, dead ends, and even random teleporters. Here, that embodiment constraint is a huge deal. One wrong turn, and you're stuck. To learn this world, you absolutely positively need a smart plan. And the final test was the 1-2-3 world. This one tests a completely different kind of learning. The structure here isn't about space, it's about probability. The agent has to figure out that one action always does one thing, another action leads to one of 2 things, and a third action leads to one of 3 things. So, how did our agent do? Well, the results in the maze, they're a total game changer. This chart shows how much information is still missing from the map, so a lower bar is way better. You can see that random wandering and even the simple one step at a time PIG strategy, they really struggle. But PIGVI, the agent that plans ahead, wow, it learns the world dramatically faster and way more completely. It's not even close. So this proves the strategy works, right? But it kind of brings up a deeper question. What's the real point of all this? What's the ultimate reward for building this perfect map? The answer, it turns out, is something way more powerful than just knowing stuff for the sake of knowing it.
The real prize is something called generalized utility. See, the evolutionary advantage of being curious isn't about solving one specific problem today. It's about building a master map of the world, a really rich, accurate internal model that you can then use to solve any future problem way more efficiently, even problems you've never even seen before. And what can this master map do? Well, with it, an agent can instantly figure out the fastest route to a target. If rewards suddenly pop up on the map, it knows the most efficient way to grab them all. It can adapt to totally new challenges without having to relearn everything from scratch. It is the ultimate, flexible problem-solving tool. And look, here's the final proof. When they tested the agents on brand new tasks, the results were crystal clear. Our curiosity-driven PigVI agent was a top performer on everything. It even beat a state-of-the-art model that was specifically designed to chase rewards. Just think about that. Pure curiosity built a better all-around tool for survival. And this brings us way beyond just AI agents. This simple model gives us a really powerful way to think about the purpose of curiosity itself, not just in machines, but in us too. Because at the end of the day, this algorithm isn't just a bunch of code. It's a mathematical model for the exact same force that drives a baby to figure out all the sounds it can make, or what pushes a scientist to design that next big experiment. It's the same force that fuels our own deep, innate desire to simply understand the world and figure out our place in it. And that leaves us with one last, really big thought to chew on. In a world that's always changing and full of surprises, maybe the drive to get a specific reward isn't the most important thing for long-term success. Maybe the most powerful, the most adaptive, and the most fundamental trait for survival is just curiosity.